I'm Federica Bressan, and this is the first episode of the 4i magazine podcast. Today, we talk about risky asteroids with Paolo Martino, principal engineer for HERA, the first European Planetary Defense mission at ESA, the European Space Agency. Let's go. Welcome to the show, Paolo. How are you doing today?
Hi, Federica. I'm doing great. Busy as always, because we have a very important mission to launch in 2024. And in the space sector, this means basically tomorrow.
All right. So is this mission related to risky asteroids?
Yeah, indeed. That would be the first time that mankind tries to demonstrate its capability to deflect potentially dangerous asteroids. So it's something in the interest of everybody.
All right, but we're talking about potential danger. Like, as of today, there is no asteroid headed towards us that we know about.
Indeed, not that we know of. So we're not talking about imminent risk of extinction. However, asteroids present a concrete threat, I would say comparable to other natural risks and disasters like volcanic eruptions, earthquakes, tsunamis, and so on. So we need to take the matter seriously because maybe asteroids are one of the natural disasters that we can, more than others, try to foresee and possibly even prevent.
So what you're saying is that the likelihood of being hit by an asteroid is not, very different than that of a tsunami or a very large earthquake.
Indeed, in average, every year the Earth is hit by asteroids. And what makes a difference is the size of these asteroids. So the Earth is hit very often by relatively small asteroids. We are talking about maybe 1 meter in diameter. This happens really every year, but the consequences are not that dramatic because such a, we can say, small asteroid basically creates a very nice and fancy firework. The problem is that from time to time, larger asteroids may hit the Earth, and those can have worse consequences. We can say that in general, there is a lot of small asteroids and few very big asteroids. Now, very big asteroids might indeed create something like the dinosaurs event, but fortunately, this size of asteroid hits the Earth every hundreds of millions of years. So we are really not at risk in terms of on a global scale, let's say. The worst ones are the one we can stay in the middle. So 10 meters, 100 meters, those indeed hit the Earth with quite high frequency, order of tenth of years or hundred of years. So for example, a 100-meter asteroid, it's the Earth every 1,000 years, but is big enough to wipe out maybe a full nation, or depending where it hits, can have really, really dramatic consequences. I mean, the energy that is developed in the impact of such a big asteroid is in the order of tens of megatons. So we are talking about several tens of times the Hiroshima atomic bomb, for example.
You're saying that these asteroids just keep hitting Earth, but most of them are small enough not to penetrate our atmosphere. But you say that some do go through. So when was it the last time that we know of, besides the dinosaurs asteroid, that an asteroid hit Earth? That hit Earth so that at least it punched a hole in the ground, if not, wiped out some large area of vegetation or animal life?
Well, sometimes people think about asteroid hitting Earth as like a projectile that makes a hole in the ground. It's not always like...
I wonder who those people are.
That is not always the case, and if an asteroid doesn't reach the ground, doesn't mean it's less dangerous. I'll give you an example. Some years ago, I would say now 7 years ago, there was a pretty famous incident in Chelyabinsk in Russia, where an asteroid estimated in 18 to 20 meters entered the atmosphere and actually didn't reach the ground. It exploded mid-air, but it released a quantity of energy. Also in this case, roughly 30 times, sorry, 3 times the one of the Hiroshima bomb. And the shockwave of this explosion mid-air had a lot of consequences in terms of injuries to people. More than 1,000 people were injured because of the shockwave, for example, shattering the glasses of the windows and the cars. And we've been really lucky that, that this event happened in, let's say, in an area with low population density. If the same would have happened over Paris or London, for example, we could have had much more effect, like injuries and casualties and so on. So, I mean, from time to time, we really see these events happening, and the danger is real. So we need to be prepared for it.
So when we are able to spot an asteroid that is headed our way, or so to speak, it has a non-zero chance of hitting Earth in some time, what can we do? Is there anything that we can do?
Well, indeed, the scientific community has been studying for several years what we can do, and there are several options on the table. Those depends basically on how much time do you have in order to try and take some corrective measure. The main focus, and is a technique that we are trying to demonstrate, is what is called kinetic impactor, which is a relatively simple concept. It means we are hitting the asteroid with an object, spacecraft, a satellite, basically as massive and as fast as possible. Try to nudge him a bit, so deflect it of a tiny bit. But this nudge, if takes place in the right moment and in the right place in the orbit of the asteroid, is enough to, let's say, we believe will be enough to dramatically reduce the chances of impact. And this is very important because ESA and NASA and all the world are monitoring all these near-Earth asteroids. And then there is a publicly available risk list of asteroids, which indeed in the next 100 years have no zero impact probability, and this list already contains roughly 1,200 asteroids to be kept under strict control. So we do need to be ready when it will be the case.
1,200. That sounds like non-zero chance. Let me ask you, so this mission that you mentioned at the beginning of this interview, the one that you're going to launch in 2024, how does it relate to HERA? Is it part of HERA?
Yeah, HERA is the mission, is the European component of the mission. We have an international collaboration with NASA. It's called AIDA, Asteroid Impact and Deflection Assessment. Which consists of 2 main missions. So we have the NASA mission, which is called DART. It's an impactor that will launch in few months, actually, and will hit this asteroid. This is called Dimorphos. Is the moon of a binary asteroid called Didymos. And it's, let's say, it's the chosen target because this moon is roughly 140, 150 meters. So it's a perfect Stroman case for the class of dangerous asteroid I was mentioning before. It will launch in a few months. Basically the satellite will crash into the Dimorphos at a speed of about 7 kilometers per second, and we believe that is going to change the period of the orbit of this Dimorphos around its main body, Didymos, by a non-negligible amount. We are talking about 5 to 8%. So minutes over an orbit of 12 hours. So something you could be even measured from ground. Then,
all right.
But this is not enough. Then that's where ESA enters the picture with this HERA mission, which instead is a mission that will rendezvous with the system in order to provide complementary analysis and in situ inspection that would allow to, let's say, upscale the experiment of NASA, which is so the NASA experiment will be: are we capable of hitting an asteroid, and will it work? Okay. In order to gather all the information that you need to actually develop and improve impact models, which are the ones that scientists will use to see if this technique can be applied to other asteroids, you need a detailed analysis of this asteroid. And this, of course, DART has no time to do because its mission is very quick. We'll crash into the asteroid, basically. And so HERA, for several months, will gather information about these dimorphos, like its mass, its shape, its internal structure. And this will allow the scientists to develop and refine models that will allow them to then assess other possible threats, whether this technique can be used for that or not. And if not, of course, we'll think altogether about possible alternatives.
I wish we could have an update on this next year or in 2 years when the ESA mission launches. But for today, I would like to thank you so much for being on the first episode of the 4i Magazine podcast. You've been very gracious with your time. I would like to encourage our audience to check out the ESA website at esa.int and to check out the 4i Magazine YouTube channel for more episodes of this podcast. I am Federica Bressan, and I will see you next time. So long.